Hi everyone, just wanted to take a minute to talk a little bit about similar triangles and how to prove that two triangles are similar. So ultimately, just like any other similar polygons, similar triangles are in the same ratio. The sides are proportional, and that proportionality um, is retained from side to side to side, and the angles are congruent. So there's three main methods for showing that triangles are congruent. Now, the first one is probably the most common, is the angle-angle similarity postulate. So the angle-angle similarity postulate just requires you to have two triangles with two sets of congruent angles. You don't need the third because the third is implied, right? They all add up to 180. And so if you know two of them are congruent, you know the third must be. So that's why you don't need to explicitly show the third. You would have side-side-side similarity, which is just that all three sides are in the same proportion. So if you can show that all three sides are in the same proportion, you can show that the triangles are similar. And then finally, you could have the side-angle-side similarity. That would be if you have two sides and then the included angle between them. Again, the two sides would have to be the same proportion and the angle between them would have to be the same. All right, so just be careful. It's not that the sides are congruent now. This is different from the congruence ones. But ultimately, that's how you would prove triangles are similar. So there are some more information here in the slides, but pretty much you just need to know that you would need to use angle-angle similarity, which is a postulate. From the angle-angle similarity postulate, by the way, that's how you would end up proving the side-side-side similarity and the side-angle-side similarity. All right, so do specify. Again, please make sure you say similarity. All right, so let's do a couple and make sure we can get this to work. All right, so we are given the information that these two are parallel. All right, so let's write that down. So we are given that information. Statement, reason. All right, so what are we given? We're given that DE is parallel to AC. Now, whenever you're getting parallel, remember that's really going to be helpful for you to say things about angles, okay? So you would be able to say some things about angles from this. In particular, what can we say? Well, we know that this angle right here and this angle right here, they're corresponding. Similar with this angle and this angle, they're corresponding. All right. So right off the bat, we can just use the corresponding angles to say, because these are parallel, that these two angles and these two angles are congruent. Okay. Alternatively, by the way, if you didn't want to use the corresponding angles, you would have to use it for at least one set. But you also could have just used the reflexive property because that's a shared angle. All right, let me write that. Let's say angle B is congruent to angle B by the reflexive. Okay, so reflexive. Now, it doesn't matter which other set I use. I'm going to say 3 that angle BDE is congruent to angle BAC. I am going to be specific with those because you have to make sure you're using the correct angles. And that comes from corresponding angles. Into postulate. Okay, now we have an angle and an angle. So we can say that these two are similar now by angle-angle similarity. Okay, so we have that triangle. An angle-angle similarity really is going to be one of the more common ones that you would end up using. All right, so angle, and I like to put the little similarity symbol afterwards, just so that way we're sure. And that's all there is to that one. Let's do another one. Oops, went too far. Okay, so we're given a side. Good start. So we're given this angle and this angle are congruent. We're given BD. Oh, these are side lengths. We're just given that these are existing. Helpful. All right. So let's go through those. All right. Well, what are we given? We're given that angle B is congruent to angle D. Oops. All right, now what are we going to do? Okay, so angle B is congruent to angle D. Well, this is a vertical angle. So when you have a vertical angle, use it. So this is going to be angle again. Again, that's the most common one because it's a lot easier to show angles are congruent than it is to show sides proportional. To show sides are proportional, you usually have to know that information, or you would have to do some sort of, it's just a lot less common, some kind of addition or division, or usually some sort of manipulation to get it. Okay, so let's do this out. Angle BCA is congruent to angle DCE, and that's a vertical. All right, now I have angle again. So I know that triangle BCA is similar to triangle DCE. So why did I do that? So the reason I did that was really just because my goal was to show that these are in the same proportion. And now I can say that because they're similar, right? So now that I know that these are similar, I can say that they're in the same proportion. And the reasoning behind that just kind of comes down to the fact that you know that similar polygons have sides in the same proportion. Okay? So, 4. We know that AB is to ED as BC is to DC. Okay? Triangles, similar triangles are proportional. Okay? So similar triangles are proportional. That just comes from the definition of what it means to be similar. So anyway, that is what you would ultimately be doing. So you want to look for angles first. If you can get angles first, just do AA. If you know information about sides, you can usually kind of figure out a few more pieces of information about sides. The times you really use sides kind of comes down to when you have like things inside of each other. Usually, if you don't have things inside of each other, you're probably not going to end up using sides. But anyway, that would be how you would go about solving or proving that triangles are congruent. Look for side similarity, side angle similarity, or angle similarity. All right, let me know if you have any questions and have a great day.